Hello everyone. Welcome to the 48th webinar in 12D's training webinar series. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator at 12D Solutions. While we wait for everyone to finish joining and get comfortable, I'll launch a polling question. You'll have about 30 seconds to answer about how water flows and then I'll show the results. Okay, we've got a lot of people voting for downhill here, and a few people have joined me on an all of the above vote, so I'm sure Owen will have a lot to say about this over the course of this webinar. Okay, let's get started. 12D's training webinars showcase common industry challenges, taking a close look at industry best practices and how these can be implemented using 12D products. The aim of these webinars is to upskill 12D users and broaden their understanding of the capabilities of 12D products. We run these webinars regularly and record them for posting through our website and on YouTube. The first 47 webinars from this training series, as well as the 44 webinars from our Industry Solutions series, are available on our YouTube channels if you missed those. During this live presentation, you'll be able to type your questions along the way, as shown on the screen, and we'll answer as many as possible throughout the webinar. At the end, I'll also read out some of your questions to the presenter for his insights if there's time. Today's webinar, Downhill Strings, will be presented by Owen Thornton, who has been writing software for 12D Solutions since 2003. Owen has 15 years of professional experience in the civil and mining industries. He is the original author of 12D's Drainage Network Editor and the Drainage Analysis module, and is a 12D specialist in drainage, utilities, plot parameter files, survey conformance, volumetrics, and system setup. Owen has recent consulting experience using 12D model on a variety of large projects. These days, Owen also gives regular 12D training courses in drainage design and macro writing. Today's webinar will discuss the downhill strings option for processing superstrings with Z values. The option has been significantly updated for 12D Model 14, and the changes will be highlighted as part of a complete demonstration of the option. In addition, for drainage designers, the interrelationship with the utility string editor will be discussed to modify the properties of the overland flow strings created by downhill strings. Over to you, Owen.
Thank you, Lisa. Hello, everyone. Yes, this webinar is covering the option downhill strings. Not just the new features in version 14. This webinar will be an overall demonstration of how to use the option for those who may never have used the option before, but also for those who have, highlighting some of the new features. Before we go too much further though, just a word on that polling question. If you answered downhill strings or all of the above, well, they're both right, really. Like most things in drainage design, there's not necessarily a perfect answer in there, and you could argue one way or another that one's more correct than the other, but that's what drainage is all about. There's often, it was a deliberately vague question, which is the way a lot of things are in drainage design. But yeah, my vote would be for all of the above if I had to pick. Back to the topic at hand though, downhill strings. Just a list of the new features and why it looks new and how it looks new. It's the old non-standard source box, and if you're familiar with the original option, it's been around since version 10, I think, or version 11. It didn't have a standard source box. It just had a model mask and a string mask for selecting input strings. Of course, this option simply requires superstrings as inputs that have Z values. It doesn't really have anything to do with drainage strings, and in fact it's not tied to the water modules or anything like that. It just comes with the base module, and you simply require superstrings with Z values, and that just happens to be what most civil designers will provide you in terms of the strings that they create when they run their apply MTF functions and things like that. So this will process those strings and determine where all the high points and the low points on the strings are, and split them at the high points and low points and point them all in the downhill direction so that they're all consistently pointing downhill. But we now have standard source boxes because the source box in the last few versions has supported model masks. It never did previously when this option was first written, the downhill strings option, but now that the standard source boxes can, we've put them on the downhill strings panel now. We also have, in fact, two source boxes, one for the basic strings you want to process into downhill strings and a separate source box for manually drawn strings. And these are strings that, because the design strings typically don't represent precisely how, say, water flows across a surface, we might need to intervene in certain places and draw some manual diversions and things like that to better represent the one-dimensional flow. We're imposing our will as designers on the water here by drawing these arrows on the screen. But we often need to combine those manually drawn strings with the downhill strings. And in the past, each time you needed to rerun this option because the design has changed or something, you typically needed to redraw all these manual strings. And now we have the ability to have you only draw them once. There still will be a little bit of joining and merging of things together potentially, but in some cases you can do it so that these manually drawn strings actually automatically join to your downhill strings. And of course those manual strings aren't downhill themselves. They possibly could go uphill in certain points as well, which we'll see when I do a live demonstration. The other thing though is, especially for those people doing drainage design with the rational method, these downhill strings are used as your overland flow model, and they can have a whole lot of very specific vertex attributes set on them by this tool called the utility string editor. And that tool can take quite a lot of work. The user can put quite a lot of information, additional information on the downhill strings with all these vertex attributes that are used by the rational method analysis to modify certain properties of the overland flow strings. And each time in the past you've rerun downhill strings, all that information has been lost. Well, no longer. One of the new features in version 14 is that you can save and reapply that vertex data from your original downhill strings, which are about to be deleted and recreated, and they will be reapplied to the new downhill strings. So overall, it requires much less work when designs change and new downhill strings are required. Typically, if the designer moves a sag point or a crest point on the road widens, or the horizontal geometry or the vertical geometry changes at all, you generally need to recreate new downhill strings, and that might happen, a handful, half a dozen times throughout the course of a job, possibly more. And so there is always a need to rerun this downhill strings, and the idea of the new features here is to mean that we need to do less work to update and create new downhill strings. Okay, so for those of you who are already familiar with this option, this is what it now looks like in version 14. What used to be a single panel with no tabs on it now has 4 new tabs. And I didn't really intend to have so many tabs on it, but what I discovered is having 2 source boxes, and there's my primary input on the primary tab there. There's one source box, and this is where you specify your strings to be downhilled. I'll talk more about that later. But there's a second tab here, extra input, and I've shown the other 3 tabs on the right-hand side here. This is all really part of the one panel, but I've just expanded out with a little bit of Photoshop magic. And on the extra input, there's another source box. And you simply cannot fit 2 source boxes on a single tab and still have it fit on the screen. In some cases, depending on the mode you set the source box in, it'll make the panel so big that it doesn't fit on the screen anymore. So they really need to go on separate tabs. And just for balance, I added 2 extra tabs for the basic and advanced settings there, broken it up into basic and advanced. The basic settings are pretty much unchanged, largely unchanged from the way it was pre-version 14. And I've moved the splitting options, where you can split the downhill strings at drainage inlets. I've moved that onto the advanced settings. I'll talk a little bit more about that later on, but I don't tend to use that split option very often. In fact, the main reason why is I often run the downhill strings option before I've even got a drainage model. Now it does have applications, specifically once you get into the 2D side, when you're doing combined 1D, 2D modelling. There is a very good reason for splitting your downhill strings at the drainage inlets, but most of the time it's actually a disadvantage, especially for rational method and dynamic drainage, because if you have downhill strings that are split at all of the drainage inlets, it means you can't move your drainage inlets, say change your pit spacing along a curb or something like that, without recreating new downhill strings. So I see that as a big disadvantage, which is why I very rarely use these split options. And this other setting or box here, vertex, text and attribute data, I'll demonstrate exactly what this is. This is all about being able to save the original vertex data from your original downhill strings and reapply it to the new downhill strings. I'll talk a bit more about that as well. So that's the new look there. It looks a little bit more modern with the new source boxes and extra tabs there. Okay, and of course in version 14 we have revamped what used to be known as the drainage menu. It is now the water menu. And so the downhill strings has a new location on this new and improved water menu. It is now under the water main menu. Under stormwater tools, you'll find the downhill strings option. It's a little bit more, a little bit easier to find, I think. You'll also find it under this stormwater tools menu has been duplicated under the water strings sub-menu as well. But to be honest, all of these options under stormwater tools, they aren't necessarily related to the water string. At least, you know, you don't have to go and do anything with water strings to run any of these options under stormwater tools. So they've been separated out and put on the main water menu there. But also, we have what used to be the drainage toolbar is now referred to as the water toolbar. And just below the rain cloud there, if you press down on that, you'll get this rather nice looking downhill arrow, which is the icon for the downhill strings option. So we'll be demonstrating this in just a second. And in fact, let's do it now. I'll switch over to version 14 now. And we're going to run the downhill strings option on this job here. You can see it's a sort of a subdivision job with a network of roads and there's a channel running down the road here, down the hill. It's high at the top of the screen and low at the bottom. The general flow is from top to bottom. I'll just maximize this view, in fact. And I've got a detention basin at the bottom. And when we talk about running the downhill strings, we're typically wanting to process our design strings, which are the strings I've got on the screen here. I've also in advance gone and labeled the high points, the crests and sags, the high points and low points on the drainage inverts, the curb inverts and the channel inverts. So that's what the little bits of red text are marking out. There's a high point, a couple of high points there, a couple of low points there. Around these curb returns, there's, you know, crests and sags and what have you. A couple of the curb returns have markers as well, and so forth. So that's where we're starting today. And I can either go to the water menu here and go stormwater tools downhill strings, or I can go to my water toolbar, which I've pinned up here just below the rain cloud, go to the blue downhill strings icon, and this is what the new panel looks like. Now, if I wanted to process everything I see on the screen here, or at least the strings, not the text labels or anything, you can see my model list here. All of my design strings are in models called design something. Okay, that's how this job has been broken up. So in my primary input tab, I can come over to the filter icon and go to the model tab within the filter icon and type in design star. If I hit filter select now, that'll tell me what that design star matches. And basically it's highlighted everything. And that's way more strings that I'm interested in downhilling. I'm really only interested in downhilling the strings that are going to be useful for me from a drainage point of view. And that's typically the inverts or overland flow paths, the bottom of those, basically the inverts of your curb and channel. or curb and gutter on your roads, and the inverts of your open drains and things like that. So in this particular job, I can scroll all the way over to the right here to the third last tab on the filter icon of the source box and go to name masks, and I can say, well, in my particular job, all my curb inverts are named KI star, KI left and right, and I'll add another row there. I've also got all my table drains. I've got a channel here and a channel down the top there, and that's called DI for drainage invert. If I go filter select again, it's now only highlighting, it's a bit hard to see the highlighting, it's now only selected 25 elements from 6 different models there. Okay, so far so good. What am I going to do with these downhill strings? Well, I'm going to create them in a new model, and I'm going to call it dr space bypass, and I'm going to automatically add it to this view, which is comma dr in capitals. That's the name of this view, dr for drainage. And if there's any strings in there already, in fact there isn't in this project, it's a brand new model, it'd clean out the model beforehand. So before we go and look at some of the other tabs, I'll look at the basic settings, which are things that all of the settings on this tab already existed before, but a couple of new features are that you don't necessarily need to specify a color or a prefix anymore. It will use the original prefix or the string code and then add a numeric suffix. And you'll always get this unique numeric suffix because ideally we want these downhill strings to be uniquely named. So I can happily leave this blank, and I can leave the color blank, and it'll give me the downhill string in the same color as the original string. Okay, I will apply a line style though, and this levy tolerance, this is the default of 25 mils. That might be a little bit high here. If you set it to 0, you're basically saying that you've modeled everything perfectly and there's no little vertical wobbles in any of your strings. And this is a pretty good design here. I probably can go a little bit lower than 0.025. I'm probably be inclined to go 0.05 or something like that. Maybe a little bit lower. You can push it right down to 0 in some cases, but I think I'll leave it there. That's the only thing I'm going to change though. I can leave the joining options, and it will, through all the different string model changes and string changes where we go through curb returns and things like that, it will go ahead and join the strings together. So I should get continuous strings from the high points all the way down to the low points, joined head to tail. And for the first run, I'll just leave it at that. I'm going to leave the advanced settings completely unspecified. The basic settings, I've only changed the levy tolerance. I've got no extra input there, and I've simply come into the primary input and specified my curb inverts and drainage inverts. Let's go ahead and hit the run button, and automatically on the screen I can see if I take the design models off, which is what this was originally based on, I've got a new model called dr bypass, remove the design models, and I just see these now. And if I can highlight the various elements there to see, well, I've got one continuous string from here. Now that's a crest right there. There's my crest marker. You can see it highlighting in yellow. It's going all the way down to the sag down here. And none of this is new. This is the way the option always behaved in version 12 and before that. So there's nothing really new here other than the fact that the original colors can be maintained if you like that. Okay, so if you wanted to, you can see that if I go to models string info table, I can see that every string in this model has a unique name, and it gets the original string code. It's either a KIL or KIR or a DI something in there as well. And I get a numeric suffix from 1 through to the number of downhill strings in the model. Okay, so far so good. However, most of the time when you've got a road network with possibly channels as well, there will be places in this design where the strings provided by the designers even after they've been downhilled, are not going to represent precisely the way that the water is going to flow across the road surface. And typically that's around your intersections, like here. T-junctions are a classic, especially where you've got the side road is flowing down into the T-junction. It's not so typically so bad at a T-junction like this one, where the side road is flowing away from the T-junction. But these two have the T-junction or the side road flowing down to the T-junction here and here. Also, you might need to do some extra work around low points to say that, well, actually, if the water gets to this low point, it's going to start forming a pond until that pond spills, and that's going to spill somewhere. And we need to provide, at least if we're going to use these strings for an overland flow model in drainage, say, we need to say where that overflow is going. And this is the art of 1D modeling, I guess. It's drawing arrows on the screen and imposing our will on the water. You generally don't have to mess with any of this sort of stuff if you do 2D modeling, because you just provide a surface and add water, and the governing equations are solved, and it works out where everything, where the water flows. Okay, so that's where this extra input comes in, because in the past you'd have to go and manually modify these strings. However, if I just happen to have a model here called Drainage Bypass Manual, I'm going to add that onto the view here, and just in a handful of locations here, rather than say this string, in this case at this intersection, flowing around the corner and down to the sag point here, we can notice that the road, which is in between the two grey strings, the road is in super elevation on one side. And so it's only really a one-way crossfall on this road. And so the water isn't actually going to follow this curb. Well, a very small amount will follow the curb and gutter in there, but that's barely worth modelling, because the vast bulk of the flow is going to spill out of the gutter and across to the other side, where there is some kind of reasonable channel forming in the tin surface. So that is a better representation of the way the water's flowing. Likewise, up where this hammerhead is here, I don't personally think it's worth modelling any of the channels in this hammerhead there. I'm really just interested from at the top of this green string, it'll sheet across the surface and then start flowing into the gutter here. So a lot of this stuff here with a one-way crossfall, that's probably the trickiest thing to do here. This green string here, there's actually an easement in this job, a stormwater easement, and this would be picking up potentially interallotment drainage and a sag pit from up here, coming down to this overall the two sag pits right down the bottom before we go into the basin. Okay, and so that's these strings, of course, these green strings weren't in the original design string, so we have to add them ourselves. Similarly, at this intersection, this is a better representation for how the water is going to get from these three upstream paths to this single downstream path here. It's not, there's nothing in the model to say that the water gets from this point down to here, so we've drawn the green strings to say that. Okay. Another interesting one is way down the bottom here. There's another couple of sags here, and there's also in my side drain here, or side ditch, at the side of the road, which is showing up in brown, there's a low point there too. So this is a location for a culvert underneath the road, but you'll notice the sag point in the channel is offset a little bit from the sag on the road. Now that's a good thing, because it means that you can have a separate culvert and separate sag pits potentially, and without clashing with each other. But the green string I've drawn in this case for the culvert is going to represent if this culvert ever needs to overtop the road, it's going to, the water's going to rise up the embankment here, and this is the spill point, which is the low point on the road surface. It'll actually go across the road there and then spill back to the overland channel, or the cross channel, and go wherever it goes. But it actually serves double duty there. As it's drawn, it will convey any overtopping flow that doesn't make it into the culvert, but it also is going to cross the two nodes, or the drainage nodes that we haven't shown here, but they will interrelate, and potentially the two flows from the road drainage and the cross drainage systems could potentially mix there if this culvert ever overtops. So that's the purpose of that green string there. So what do we do with this? We simply specify it on the extra input tab, and I'll just select it there. It's called bypass manual, and in fact I'm going to take that manual model off the view now. So I've got my original bypass strings that I ran in the first pass, and I'm simply going to rerun the panel now, specifying those green strings as well as my extra strings. These will not be downhilled. They will simply be added into the models and potentially joined up and potentially renamed and colored as well if you've specified colors and things like that. So we'll go ahead and rerun the panel now. Again, it's going to clean everything out first, and I'll rerun. Okay, and that's just the single bypass model. The manual ones aren't there. It's just taken a copy of them and merged them into my bypass model. And in some cases, if I zoom right into here, and you can see the original segment colors have been maintained. And if you don't like that, you can actually make them all, by specifying a color here, it will make them all whatever color you specify and remove the segment colors. But here, if I highlight this one, I can see this portion of the string has actually been merged and joined onto the end of the string coming down from one side of the channel there. Likewise, there's a couple of others that are doing similar things here. If I pick on that green one, it's actually merged it in from the high point there. You can see it coming down to the channel there. Now, I would need to put a node there if I was going to make a proper junction once I start using this as an overland flow model. But again, this process is often done before you have a drainage model or a water model. It happens before then, and it's often used as the basis for creating your water model. Okay, it's not always so neat though in cases like this one. So this green string that I started here and this other one that I started here, they are placed in locations where I think they're a certain distance upstream from the curb return, and that's where I'm intending to place pits. However, these ones haven't merged into the white strings or the grey strings because there wasn't a stop and start in the strings, in the original strings there. So I'd need to do a little bit of manual intervention there. And all I mean by that is I'll do a quick example here. I'll just work on, say, this one. Down here at the sag pit, I don't need to do anything. That's all working nicely. But again, it's this string is not only conveying the flow from coming down the easement, but it is also conveying the sag pit here. Once it bypasses, it's going to spill over to the other sag pit, and this sag pit will spill into the basin. There's a nice cascading arrangement there. So that one's already done. But if I were to I'm not going to go through the whole model here and fix this, but just to say that, hey, well, now you can do a little bit of intervention. And what I would do here typically is I just bring up my strings edit menu and go, I'll split, and I'll tick on the control point option there, and I want to split this grey string right at the start of that green string, like so, and I want to split this grey string right at the start of this green string, and I want to split this grey string right at the end of that green string, like so. And then I'm going to delete the leftover bits, which is that bit, and so that's pretty much it actually. So I now have one of my original grey strings. I've now stopped it there, and this is just really more of a personal preference, but when I'm modelling a T-junction like this where the side road's flowing down, you've typically got 3 approach paths merging into one there, and I like to have this through road as a continuous string there. So I would then come up and join and say I want to join that one to that one and that one to that one. And I now have one nice continuous bypass string starting all the way from this crest all the way flowing down and around the hill and down to the sag there. And these 2 side roads, well, the 2 paths on the side road there, they will end up going to the same point. And another point to notice here is this one here, where the road gets very flat there and the water is really just sheeting across the road there. There's no channel to form, so don't worry too much about precisely how the water gets to this point. It's really sheet flow and not worth modelling as overland flow or flooded width strings, I should say. What is important though is that anything that doesn't make it into the pit that we are proposing here is going to bypass and make it to that point, and it will convey the flow rate without necessarily seeing how it happens, because once you've got sheet flow, flooded widths are a bit meaningless. They're very, very shallow and very, very wide, but it's not enough to get your shoes wet. It looks bad on the screen, but they're really things that can be happily ignored because they're so shallow. So sheet flow is something to look out for, and it often happens in intersections like this. And that's, you know, I could go through the rest of the model and do that, but I won't. What I will go on and say is, as well as you know, making a few geometric changes to the downhill strings option, you often want to run the option, if you're running, especially if you're running the rational method, you often want to run the thing just below the downhill strings option, which is the drainage utility string editor. Now this, it's not really needed for the dynamic drainage or anything else, but there are these 3 variables here that we can set at particular locations along these overland flow strings to change default properties. And typically at an intersection like this, where I want to, you know, if I have a node here, say, I want to figure out how much of any catchment that's assigned to the node here, how much of the catchment flow comes down each of these paths. And I typically like to model this sort of system where the 2 side paths here are only used to convey bypass flow, and this is where the catchment flow comes in. And really, it's up to you how you choose to model this in some cases, because nothing about what we do here affects how much actual flow ends up coming to this node. It's just how we apportion it and how we represent it on the surface before it gets to the node. And in my case, I might choose to have 100% of the catchment flow coming down this straight through line, and at this point and this point where another node would be on the other side of the road, I could use this option here to set these 2 reaches from this point down to there and this point down to there with only conveying bypass flow. And that's easy enough to do. First of all, I'm going to start off by highlighting the vertices here. So I'll just toggle on the vertices just for my bypass model. And they're a little bit hard to see in cyan, but I'm going to use the pick button there and jump right on the beginning of, or actually I missed a step. I just wanted to do one other split there. Strings, edit, split, and I want to split this white string at the beginning of that green string, like so, and delete that bit and join that to that. So I now have one continuous line going down to this point, this curly one going down to that point as well, and this one is nice and continuous. Okay. So using my utility strings editor, which I accidentally got rid of under the rain cloud, there it is, and I'll pick on this vertex right at the top of this line here, and I can simply set the QDC percentage to 0. Now to get it to display nicely on the screen, you typically need to set a text style as well. I'm going to just use this one for now and just edit it. The first one on the list, the text data favorite. Go and edit it. I might make it a different color, orange. I might make it paper scale text. Might make it 2.5 mil. And I'll make it bottom left justification, and that will do. Set, finish, set. And that puts a little label there saying that from this point, from this vertex on the bypass string all the way to the end, this thing takes no direct or catchment flow. In other words, it only takes bypass flow, which is the way I want to model it. And I could do a similar thing on the vertex on the other side. And in fact, it looks like I don't have a vertex there, so I can go and create one. So I'll just use my CAD vertex tool and say I want to do a between there, and I want to insert a vertex on this string perpendicular to the other one, so because I'm going to have 2 pits on either side there. Now go and pick this one that I just created right on the vertex there. If you don't get the vertex you particularly wanted, you can use the little arrows on this utility to move from vertex to vertex. But that's the one I want, and again I want to set that QDC percentage to 0 and set. And that's the typical process with this utility string editor, and you can go around and do all sorts of things there. But I'm not going to do the whole thing. I'm just going to save a little bit of time here. I'll toggle those vertices back off because I have a chain that is going to sort of get me to a finished state here. Now this is what I would call, I've already gone and processed this to completion now, and this might be the previous run of my downhill strings. And I want to demo it this way because this is one of the new features that I want to show off now, because all of this extra information that's in this model now in these orange bits of text, without going into the detail about why it's been added and what have you, all of that little bit of information, in the past that would have all had to be redone. And I've got quite a number of these little vertex attributes all over, dotted all around this model to say that there's extra modifications to be done to this network. And the thing we can do now, as well as having our primary input and our extra input and our basic settings, we can come over to the advanced settings there and say, well, if I want to rerun this, I want to use my original bypass string, so that chain I ran before just simply updated my bypass model to copy in the finished one. So here's one I prepared earlier, in other words. But that's going to, I can get those little bits of vertex attributes and vertex text by, first of all, ticking on the first tick box. That says clean and recreate vertex data from initial downhill strings. In other words, take the vertex data from these original downhill strings that I'm just about to recreate, and I'll put them in another model. And this is sort of an intermediate model, if you like, or an interchange model, because not only can I take the vertex data off and put it in this model, which I'm going to call DR bypass modifiers, it's going to take it and put it in that model there. And the most common way, you can then just automatically apply it to the new strings. Now, for the demonstration purpose, I might just do it as a 2-step process. So the first time I rerun this, go ahead and rerun it now. Now you'll notice my vertex data has just disappeared. And look, all of the original downhill strings are there. I need to go and do a little bit of splitting and joining again. All of that work I did before is undone. So it's not perfect, but it's less work than it would have been in the past, because you don't need to recreate these green strings completely. You just need to do a little bit of splitting and joining to connect the dots, basically, but where the grey strings to flow into the green strings and so forth. However, that little bit of extra information that we extracted off the original data there is in a model called DR bypass modifiers. Now, that's all the original data there, and these are just point strings. They're completely separate now from the original bypass strings, but they are little points with vertices on them. And in fact, you can use the utility string editor here on those individual points. And let's say, well, just for the sake of argument, I'm going to pick not that, but the actual point itself. I could change that to say 45% and hit set. Or I picked the, that's changed the scale on for some reason, don't know why. But I could also go and move that if I wanted to. If I go and move this vertex, and it's the modifier that I want to use. I'll use this option actually, the CAD vertex move, and just pick on that one. And I could move it, say, somewhere further up the string, somewhere a little bit offset from there. Now the key here, if you just go and rerun it again, you will have lost that information. So be careful when you're running it as a two-step process, because I don't want to clean and recreate that anymore. I'm going to tick that one off, but I'm going to apply the bypass modifiers and to my new bypass strings, because these bypass strings are going to be recreated again, just completely deleted and recreated, but this bypass modifiers data is going to be reapplied. And there is a search distance, so it will only reapply to the strings if this vertex data is within 2 meters of a string. And the trailing distance is basically if you've got a situation where there's, where's a good example here, where there's a few different strings at one of these vertices, it's going to favor the upstream portion of a string rather than applying a vertex attribute right at the downstream end of a string. That serves no purpose, because these vertex attributes apply all the way to the end of the string, but it doesn't really do anything if it's right on the end of the string. So with this trailing distance, it's basically saying don't set one of these vertex data properties on any vertex that's within 1 meter of the end of a string. So if there's lots of different choices there where this vertex snaps onto, anything within 2 meters search distance, it favors the more upstream strings there. Okay, so I can take those modifiers back off the view. I'll keep an eye on what's happened here now and go and rerun the model. And lo and behold, that 45% has come back because it's been applied from the modifiers model. So you could, in fact, maintain this modifiers model as a separate thing and move it around, what have you. The main reason it's there is because your road design might have changed significantly. The roads might be wider, there might be a road disappearing, and we don't necessarily want this information to disappear if it doesn't get reapplied somewhere. You'll be able to do a cross-check against this model and your new model to see, did everything get applied that I expected it to? If not, you might need to change some things and all of that. We just don't want that information to disappear. But they're the new features basically, and I think the biggest time saver is probably this thing with the vertex text and attribute data, but also the extra input there. Where you've got these green strings, you only have to draw them once. Yes, each time you rerun it, you still have to do a little bit of splitting and merging, but there's less manual work to do each time, and hopefully that's going to speed up the process each time the road design changes and you need to reproduce a new set of bypass strings. So that's the extent of the demonstration basically. So I've shown you the toolbar and the menu item and run this option now and shown you all the new features I can think of. So it's time to open up the webinar to see if there were any questions while I was talking.
Thanks, Owen. A couple of questions came through. I'll have a look at here. So Karen in Melbourne has asked, why do we need a separate vertex data model? Why can't it just transfer the vertex data from the previous downhill strings to the new ones?
Well, in theory it could, but there's a couple of, and this is back here on the advanced settings, why do we need this model at all? Why can't it simply transfer all of this without having this intermediate model? Well, in theory it could, but in theory then you still need a search distance. You don't want to go willy-nilly applying this, vertex to, something that's 100 meters away. And if there isn't anything from 100 meters away, that little information that was in the original model will suddenly be lost if we don't have this intermediate model. So this is sort of a halfway house for this data, and it's there as a safety mechanism more than anything. Look, once you've got the data in both, or even from the word go, the way I demonstrated it is it was just for demonstration purposes. You can have both tick boxes on, and if the data is on the original bypass model, as it is here, I can simply rerun that and everything's fine, and you can just never even bother looking in this model. But it's there as a safety mechanism, basically. It also means that you can modify, using the utility string editor, you can modify the stuff in this model and have it independent of the vertex attributes on the bypass strings. In fact, if you have one of these modifiers, and you can see the modifiers have the little crosshair symbol on them, and you can move them around. They don't have to be on one of the vertices of the string. They can be off the string, in fact, then it will drop within the nearest 2 meters. And if there isn't a vertex where it drops onto, it'll actually insert a vertex. So there are some advantages in having this model, and it's a safety mechanism more than anything. So it gives you more options, basically, and that's the main reason why we have it.
Thanks, Owen. We've had a few more come through, so I'll just read out a couple of these. Nicola in Queensland has asked, when you set 0% at the top of a string to only take bypass, do you need to set 100% below the receiving pitch?
Well, yeah, there's good eyes there. I will show you the example. I didn't really talk about that explicitly. I'll turn off those modifiers again. But here's an example where at this point here, and this is where the road's in super, and I often do this. Now, in reality, I would split this and get rid of this portion of the downhill string there, because this is really where the catchment starts. You can see the contours turning around. That's really where the catchment starts to flow down to this sag pit on the top side of the road here. And so I would have the catchment starting there and the bypass string starting here as well, but I'd set the QDC to 0 and then have it kick in at around at 100% around about this point. Now this is by the time the contours have turned around a bit and a channel starts to form in the gutter here. Before you get to this point, the water that's making its way down the catchment here as the contours are turning around, that's all sheet flow and it's barely worth modelling. But having the reach starting up there and set to 0, at least the flow rates are accumulating there. So the flow rates gradually build up along these overland flow strings, the catchment flow rates. So by this time, so this is, so if I imagine there's a node here, and this is the top of the reach here. By the time I get here, I'm about, a third of the way down the reach, say. And so I would, the flow rates would go from 0 to 100% of the flow, but I'm going to say nothing there, and then suddenly I'll get all of that sheet flow starting to accumulate into the channel there. So that's, and I think that's probably the most accurate way of modeling it when the road's in super elevation like that. I think that also here, the reason I've done it on these two locations there is I've got 3 approach paths, and I'm only really interested in this main flow path there. These ones, I'm only using these 2 paths there to convey bypass flow. So QDC doesn't mean there's no flow, it means there's only bypass flow. So I hope that's a good answer to your question.
Nicholas actually followed up to ask why you halved the flow halfway down the string.
Okay, that's the other thing is some of the interventions you need to do on these bypass strings. Anytime you've got a node that has more than one approach path, you're basically saying, well, okay, if you don't do anything, it assumes that 100% of the catchment flow comes down each of the approach paths, and that's going to over-predict your flooded widths. So we leave it to you then to say, well, to refine your model and say, well, you can make a better estimation. In this case, I've got 3 approach paths coming towards this sag here. The one across the road you can see has got a QDC of 0 set all the way at the top here, and that applies all the way to the end of the string. So that is only for conveying bypass flow, and these 2 approach paths for the 2 sag pits on either side, I've just called them 50-50 or 50-45. I should have made that 55 or 50 or something like that. The numbers don't actually have to add up to 100%. They can add up to a little bit more than 100% if there's some uncertainty, but you can probably do better than have them add up to 200% or 300% if you don't do anything, which is what will happen. None of that, by the way, affects how much flow actually gets to and into the pit. That's already been predetermined. We're simply after we've figured out what the rational method has told us, we want to figure out, well, how does the water get to the node? And this is sort of a preliminary calculation, if you like, before you actually worry about what gets into the node. But nothing about what you do with these percentages affects how much flow gets into the node and into the pipe system. It's just purely talking about how the catchment flow assigned to each node comes down each of the approach paths towards it. And again, it's only the nodes that have more than one approach path that you need to do anything.
Thanks, Owen.
Okay.
I'll just read out just a couple more of these. So Harshit in India has said, when we transfer the models to another data format, will it transfer the intelligent model or just the strings with Z values?
Depends what other data format you want. You're really only adding this vertex information for the benefit of the rational method analysis inside 12D. Nothing that I'm aware of outside of 12D will use this information. However, whatever, it depends on what data. If the data or the software that you're using can handle vertex attributes, then yes, the vertex attributes can go there. These, if I just do an F8 on any one of these strings, and I'll do it right on that vertex there, it's really just vertex attributes set at particular points there, and there's the QDC percentage there set as a vertex attribute. Okay, so that's what's going on there. So if the export and your package outside of 12D supports vertex attributes, not many do, then yes, all that information can go along with it. But for what purpose, I don't know, because it's only really useful to the 12D model rational method analysis, and that's what uses these attributes.
Thank you. And just one more live for today. John in Sydney would like to know, what is the difference between the levy tolerance and the discard tolerance?
Yeah, okay. Let's back on the basic settings here. And look, these 2 settings haven't really changed at all in version 14. They're the same as the way they always have. But there are these 2 tolerances there. The levy tolerance is basically we don't live in a perfect world. If your original design strings have wobbles in the Z value, so there might be a tiny little glitch or something in the design where it continues going down, 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 and then it might just go ever so slightly up for a fraction of a millimeter and then down again. Well, basically, setting the levy tolerance to 5 millimeters is saying that your string, when we assess where the crests and sags are and figure out which way is downhill, your string is allowed to go downhill for a portion and then rise up by as much as 5 millimeters before going down again. As long as it goes down again and that rise is less than 5 mils, it ignores that and doesn't treat it as a crest and sag, and it continues on and gives you a continuous downhill string. So that's the levy tolerance. The discard tolerance, again, and this one's set to 100 mil. After all of the splitting and joining and reversing that the downhill strings option does, basically, if you happen to have any strings left over that are 100 millimeters in length or less, it simply deletes them. Okay, so if you leave that discard tolerance set to 0, it doesn't delete anything, but you may have point strings left over which are not going to serve any purpose in an overland flow model, but for whatever reason you might want them, but most of the time you want to get rid of them. You could even set that to longer. A 100 millimeter long overland flow string is really not serving any purpose at all.
Thank you, Owen, and thanks to our audience for your questions. Sorry to those we couldn't get to live today. We'll answer you by email soon. We've got some great training courses coming up in Brisbane, Melbourne, Perth, and I think a few other locations coming up soon. The handout available on this webinar outlines what's in some of these, and you can register through the training page of our website or contact us by email for more information. The recording of this webinar will be available in coming days through our website and YouTube channel. Our next 12D training webinar is curb return and cul-de-sac design on the 20th of September, so jump onto our website and register now for that one if you haven't already. We've got more great topics coming up that we'll be setting very soon. We'll keep you posted on all of that through email and social media or if you're subscribed, and if you need to contact us in the meantime, our details are on the screen now. That concludes our presentation for today. Thank you all for attending, and we hope to see you at future webinars.